This is the Books Podcast presented by Tim Hague.
If you looked at the weight of all living vertebrates, only about 1% of that is wild. Of all of the birds, 60% are domestic chickens.
I ask you, gentlemen of the jury, is this the kind of book you'd like your wives and servants to read?
It's unusual we have a book on the Books Podcast that comes already garlanded with honours, but Otherlands by Dr. Thomas Halliday is about to be the Waterstones non-fiction book of the year, and it's also Stanford's book of the month. And I have to say as well, it's an eye-opening and fascinating read. Thomas, thank you for joining us on Books Podcast.
Thank you for having me.
We're going to need to get a sense of what Otherlands is about. But before we do, there's actually a decent story about its publication, isn't it? The road to publication.
Sure. Well, I mean, this was something which I had been, an idea which had been going around my head for only really a couple of months before I sort of put pen to paper back in 2018. And in the end, submitted it as a proposal, just a draft chapter to a potential agent, and about a week later, that agent called me up and said that she wanted to represent me. That's Catherine Clark. Mm-hmm. And I went to meet her, and we tweaked my proposal, sent it out to publishers, and within 2 months of having submitted it to the agency, we had, I think, a 7-way auction for
a feeding frenzy is what you had, isn't it?
Yeah.
Fantastic. That has to be a very unusual story.
I believe it is. I mean, it's. I understand from Catherine that taking authors from the slush pile, as they call it, is an unusual step. But I mean, for me, it's all been just a world which I didn't know at all to begin with, and so I don't really have anything else to compare it with. And I've just been letting things happen ever since.
Okay. Well, what was that idea then that you pitched to them?
Well, the idea really is to take Earth history in a series of snapshots, really. So the world has changed hugely in the last 500 million years, and when we look at the past,
500 million years.
Sure, and when we look at the past, we tend to think of only a very few of those time periods. We tend to lump dinosaur time together, even though that was 150 million years.
One of the things I didn't know, that Stegosauruses and Tyrannosauruses would never have met because they were separated by
by about 70 million years.
Yeah.
Yes, there's more time between Stegosaurus and Tyrannosaurus than between us and Tyrannosaurus. So all of these long time periods tend to be lumped together. And across all of these time periods, we would have had specific locations that had characteristics that, the landscapes that are around today. We've got deserts, we've got tundras, we've got rainforests and coral reefs, and all of these are different environments that we can visit in the world today. And the worlds of the past were just as heterogeneous. They weren't
just less asphalt.
Less asphalt, absolutely. And but we're going back before grass into the Mesozoic.
Grass. Do you know that was the first thing that made me go, ooh. So tell me about grass. It had not occurred to me that there was a time before grass, and yet it's really quite recent.
Sure. I mean, we have this sort of holistic idea of what an environment means, and the plants tend to sort of fade into the background. But of course, they've evolved too. And grass is one of these sort of hardy species which is adapted to our current relatively cold Earth. Grass evolved probably about 70 million years ago in South America, where they were relatively minor parts of the ecosystem. So, they overlapped with dinosaurs that little bit, but didn't really become at all dominant until much later into the in the Oligocene, which is about a sort of 40 million year gap. And from then they sort of spread out all over the world as the Earth began to get cooler. With Antarctica becoming covered in ice, and changes in atmospheric and ocean currents began to sort of transform the Earth's climate from greenhouse to icehouse. But today, grasslands are the most widespread ecosystem on the planet, and in fact, the largest single contiguous ecosystem that has ever existed on the planet that we know of is the Mammoth Steppe from 20,000 years ago, which stretched from all the way from Portugal across Eurasia all the way to Alaska. So grasslands can be huge and are absolutely dominant today, but they haven't always been there.
So you start off with recent ice ages and things. So you start off in the sort of recent large period and work backwards. The first chapter that we meet is sort of the period since the dinosaurs, and then you work backwards through your 500 million years. Why backwards?
I wanted to ease people in to some extent. So if I were to throw the reader in 500 million years ago to where there are organisms that are just unlike anything that is around today, there's nothing familiar to latch onto. I thought it would be quite a disorienting experience, right? I've described this before as kind of like a travel book, in the way that I've approached it. And so, we start at home and we head backwards.
Well, very explicitly a travel book, because what you've done is you've sort of inserted the reader as a point of view, even though clearly there was nobody observing way back then, and we get so far back that there isn't sight or hearing going on. But in fact, the chapters all open as sort of dramatic present. It was a fresh spring day in the early Cretaceous or something like that. But essentially, your objective is to put you and me there, standing there watching these things happening.
Yeah, absolutely. I think you can interpret it as you being there. You could interpret it as a fixed camera, almost a kind of cinematic approach, I suppose. But yes, it's meant to be immersive. So not just we think of fossils as being those bones that we have mounted in iron in the museum, but really they represent living organisms, and an ecosystem that these organisms inhabited is made up of also the weather and the sort of local chemistry of the water and the soil, plants, animals, fungi. Everything comes together to create a whole place. And I think you don't tend to get a sense of what it would have been like in the past just from looking at the bones themselves.
You're very excited by ecosystems. You go back to that again and again to say this is all working together. It's all a system.
Sure. I mean, this book is, essentially what I feel like I was trying to do is to convey ecology through paleontology. So we talk about all sorts of things. So in the Cambrian chapter, which is just a little over 500 million years ago, that chapter is all about food webs and how the origins of predation and affected the evolution of animals. And these are rules that, we can see the same basic structures in the food webs of the Cambrian as we can see in the food webs of today. So these are, as far as biology has laws, these are sort of patterns, I suppose, that emerge again and again over Earth history. I mean, obviously, scientists have different focuses, and I'm just, I guess, particularly interested in the large-scale trends. So whether we're looking in one particular time period at what's going on across an ecosystem, or the sort of macroevolutionary, the big changes, the trends, evolutionary trends that happen along a lineage. But while changes along a lineage, there's quite a lot of books out there that you can go and look at that chart, the history of particularly dinosaurs or ice age creatures, or
no hominids,
no hominids, exactly. There's not really anything out there particularly that looks at a site in depth with all of its sort of aspects there.
I have to confess that I was swamped with absolute delight and the amazing amount of fascinating and remarkable things, a lot of which I did not know, inevitably. I'm inclined to cherry pick a bit. Can I ask you to do a sort of a set piece? You tell us about the Mediterranean and what happened to it in terms of the continents moving together and blocking up the Straits of Gibraltar. Can you sketch that out for us? Because it simply hadn't occurred to me that sort of thing used to happen.
Sure. Well, the Earth is made up of a set of tectonic plates that are all shifting around over time. And it happened that about 4 million years ago, the Straits of Gibraltar that separates Africa and Eurasia at one end closed, and it was already relatively closed at the other end, with Arabia touching Asia. And so the Mediterranean Sea, which was still relatively young at that time, was then cut off from the Atlantic Ocean. Now, it happens that not many rivers flow into the Mediterranean, and this was true then as well. So the rate of water evaporating from the Mediterranean is faster than rain and rivers can replenish it. And what that meant is that with the straits closed, the water went down and down and down until essentially we had perhaps a few little very, very concentrated salt lakes at the bottom of a several kilometre deep
It basically dried out.
Essentially dried out.
How long did that take?
That took, it's about 1,000 years, isn't it?
Golly.
Yeah. I think it's about 1,000 years. I mean, timings are a bit controversial, and actually probably the timing that is a bit more controversial is the question of how long it took to refill.
Well, that's the bit that got my imagination going, because you do a marvellous piece describing that, because at some point it clearly did refill, because there it is now.
Yeah, absolutely. There was what's known as a strike-slip earthquake, which is when the two plates sort of jar against each other sideways. And this lowered what is now the Straits of Gibraltar and essentially opened a sluice. So we had this shallow, weir-like structure of water flowing in from the Atlantic into the western half of the Mediterranean Sea, which had then filled up. Now, there's a big ridge in the middle of the Mediterranean basin, of which Italy is a part, and Malta and Tunisia. So across there, it's known as this Malta-Sicilian sill. That's the word. So once the water had reached up to that, and the Western Mediterranean was full, it then poured over into the Eastern Mediterranean. And we have this wonderful evidence from just outside Syracuse in Sicily, where under the sea there are these deep gouges, these canyons, which sort of show that there had been this enormous waterfall coming down off the Sicilian sill.
And I learned from your book the biggest waterfall that the world has ever seen.
The biggest waterfall the world has ever seen. This, and it's not just biggest in terms of height, so it's something like twice the height of the Angel Falls in Venezuela, which is the biggest waterfall around today, but also much wider than Niagara as well. So it's not just, it's big in all senses. This was an absolutely vast scene, and it just, of all of the scenes that if you had a time machine, where would you go, is a question that I get asked quite a lot, and that is number one on my
absolutely
sort of
and
travel
I could
itinerary.
see it, and when I was reading your book, I watched it happen, and I went, wow, I'm asking about that. There are other, all sorts of details and facts. You talk about islands a lot, because islands have a big effect. You suggest that islands promote gigantism and dwarfism. Can you tell us about that?
Well, this is a pattern that was first identified in paleontology. It was first suggested on dinosaurs by a wonderful character called Baron Notcher from Hungary, who found this fossil site with sauropods. So sauropods are the dinosaurs with long necks and long tails, like Diplodocus and so on. But at Hatzeg in what is now Romania, he found very small sauropods and suggested that Hatzeg had been an island, and that they had evolved to become smaller on the island. And then this pattern was later seen with Dorothea Bates, found fossil dwarf elephants on Mediterranean islands from, relatively recently. And we have these wonderful fossils. So at Gargano, which is the main focus of that Mediterranean chapter, there are giant flightless barn owls and giant flightless geese and enormous eagles, but also tiny deer and enormous shrews. And so there are all sorts of interesting creatures.
Let me ask you, as I say, I'm going to cherry pick. All the monkeys in South America, you tell us, derive from a tiny initial population. All the howler monkeys, spider monkeys, tamarins, marmosets, which are very, very different. Where did that population come from?
Well, that population is descended from an ancestral population that came from Africa. And for a long time, it was thought that they sort of diverged when the continents diverged. But we now know that happened far too long ago for it to be relevant for monkeys. And so the prevailing idea is that they rafted across the Atlantic. We know that in big rivers like the Congo, if you get a storm, quite frequently big chunks of forest will be detached from the bank and hold together because of the roots of the trees, and will actually be a relatively coherent structure. These float down the rivers out into the sea. And back then, the Atlantic was only half the width it is now.
So fair chunk of sea.
It's a long way. It would have had to been, I think, at least a couple of weeks of travel, even if they're going in the right direction the whole time. But this seems to have happened a surprising amount. I mean, these long distance dispersals are. It happened at least twice with monkeys. There's been a relatively recent discovery of a second monkey population that arrived there a little bit later than the ones we now know as, quote, New World monkeys. But also rodents, all the South American rodents, guinea pigs, capybaras, and so on. These are African rodents ancestrally that rafted across. In the Americas, we have even freshwater fish and amphibians that are more closely related to those in Africa. But that's some of the most mind-bending things that we kind of think must have happened.
In the spirit of still cherry picking, I'm going to do one more, because you deal with, especially as we go further back in time, remarkable and almost unbelievable creatures. You say in your book, ask any vertebrate paleontologist which geological period includes the weirdest beasts, and they will say Triassic. Well, I'm asking. Tell me about why is the Triassic period the place to go for weird beasts?
So the Triassic comes after the biggest mass extinction of all, the end Permian mass extinction, which wiped out, according to some estimates, 95% of life on this planet. Prior to the end Permian mass extinction, the world was full of diverse animals. The sort of dominant vertebrates on land were synapsids, so things that are actually more closely related to us than to the sort of other reptile groups. But in the aftermath of the end Permian mass extinction, just as mammals take over in the Paleocene after the end Cretaceous, you get the archosaurs really rising to dominate ecological relationships in the Triassic. And so some of these are the bizarre crocodile relations. So you have, and the earliest crocodiles are sort of small fox-sized things that were walking quite upright and were probably behaving in similar ways to some foxes. I mean, we know there's an animal called Pachysuchus, which I think is late Triassic, although I might have to check that, which is sort of nicknamed the cat crocodile because it was a terrestrial predator that hunted probably in a similar way that cats do today.
And with the legs underneath the body rather than on the side?
Yeah, absolutely.
Because the characteristic of crocodiles, as far as we know, as far as we know from today, is
sure. I mean, all the crocodiles and their relatives today are occupying essentially the same ecological niche, right? They are semi-aquatic predators that are eating mostly fish and large animals. Whereas in the past there were herbivorous crocodiles like Cynosuchus, which is this sort of very strange squat-nosed creature from Madagascar, the late Cretaceous of Madagascar.
Herbivorous crocodile.
Yeah.
Fab.
But in the Triassic, you had not only archosaurs, but also the beginnings of the line that would lead to pterosaurs as well. So the first flying archosaurs, because of course dinosaurs got there eventually too, and the earliest dinosaurs, and as well as creatures which just had a short burst of bizarre ecologies and then disappear for good, which is why the Triassic ends up being so weird. So Charopteryx is probably one of my favorite species from the book, and it is known only from one site, which is called Madigan in Kyrgyzstan. So it was a gliding lizard-like creature. So if you imagine a gecko with extremely long legs, you are almost there, because between those legs and the tail there was a membrane, like stretched paragliding wing structure. With also one between its forelimbs and its neck. So it's out there, sort of jumping from tree to tree and using this sort of double delta wing structure to glide probably very efficiently through the air. The models, I mean, some people have made models to try and fly these things to see how well they glide, and they're not bad. And there's a possible relative as well of that called Ozymek from Poland. And these are the only two specimens that we have of this sort of bizarre group, which was possibly quite widespread if we know it from, what is now Kyrgyzstan and Poland. They're quite
because of course
all
fossils are a chance thing, aren't they?
Yes,
it's not like...
and certainly the site in Kyrgyzstan is really, really far inland for a fossil site. Mostly fossils are deposited. Well, fossils are generally deposited where there's water, so that usually means shallow seas. It can mean deep sea. That's a little rarer. or occasionally with lakes, but our terrestrial fossil record, the record of those things that lived on land, is so sparse compared with the endless record of ammonite shells and everything that lives in the ocean. The data is just so much better. But Charovipteryx is one of these creatures from a very rare terrestrial site from the Triassic, and so. It's kind of like a window into what we could have. Mountains are erosional environments, right? So we will never find a mountain dinosaur unless it happens to have been preserved in a mountain lake somewhere. That these are very, very rare events. It's a huge bias in what we have preserved of the stories that we can tell.
You can't help drawing some conclusions about the present catastrophe, because people have said that the current era is like the sixth mass extinction, and we can take personal credit for that one. So in fact, in the book you say the planet looks like a post-extinction world right now.
In some senses, yes. So when I say that, I'm talking about the diversity of creatures that's around. So if you looked at the weight of all living vertebrates, I think is the group that's If you look at the weight of all living vertebrates, then only about 1% of that is wild animals today. All the rest are either humans or domestic animals.
That's incredible, isn't it?
Yeah, and compare that with 20,000 years ago when there were humans, but no domesticated animals, or compare that with 6,000 years ago when we began to have domesticated animals. Even then, the number of wild animals, of course, the mass outweighed us hugely, and this is partly because we've tended to kill a lot of those larger animals when populations of whales have crashed over the last 200 years, but are building back up again thanks to conservation efforts. But yes, the particular thing that makes it look like a post-extinction world is that of all of the birds, 60% of them, are domestic chickens.
Of all the birds in the world?
Of all birds in the world.
60% are chickens?
Yes.
That's a mind-blowing fact. It's exactly the sort of thing that I kept writing down as I was reading the book. And as I say, I'm swamped with stuff like... I'm going to have to read it again so that I can trot this out at dinner parties, because the material in here is explosive and absolutely ravishing. Thomas, thank you very much.
Thank you.
The book is Otherlands by Dr. Thomas Halliday. It's published by Alan Lane at £20. And as you can tell, I found it riveting.
That was Books Podcast, presented by Tim Haig. Books Podcast is a Green Shoot production. You can find out more at www.green-shoot.com, and Tim can be contacted on tim@green-shoot.com.